Good morning to everyone. Welcome to today's session. And I hope everyone of you understood what all we have seen before PO1 examination, that is under polynomial topics. And today also we are going to continue the same lesson. And before going to today's session, first we are going to recall all the basic definitions again under polynomial. And only few of the sums are there to complete this portion. And in today's session, we are going to see how to divide a polynomial by the another polynomial again, right? So let us start today's session now. So we are seeing the topics polynomials. So first one, the general section of the polynomial, we already know that. So how can we say the given expression is a polynomial? So according to the power of the variable, the expression contains only the whole numbers in the power of the variables, then that expression is said to be polynomials, otherwise not. And this coefficients a, a1, a2, a3, etc., everything are called real numbers. So what is real number? It is a combination of rational and irrational number. Okay. And look at the next one, degree of the polynomial. So how can we find out the degree of the polynomial? That is nothing but highest power of the variable in a polynomial is known as degree of the polynomial. And then 0 of a polynomial. If you substitute any real number instead of the variable in a polynomial, if the value of the polynomial becomes 0, then the particular real number is said to be 0 of the polynomial. Okay. And division algorithm. If we divide one polynomial by the another polynomial, we will get quotient and also remainder. So this can be written in the form of P of x equal to x minus a into q of x plus r of x. So here P of x is dividend polynomial and x minus a divisor of a polynomial, and q of x the quotient of the polynomial, and r of x the remainder of the polynomial. So every division algorithm can be expressed like this only. Okay. And the next one, remainder theorem. So what is the application of remainder theorem? We can find out the remainder without actual division. Okay, we can directly find out the remainder without actual division. For this purpose, we are using the remainder theorem. So next to factor theorem. So what is factor theorem? So the application of factor theorem is nothing but we can check whether the given expression is a factor of another expression or not. Okay, for that application, we can use factor theorem. Okay, and look at the example now. So what is given here? So it is a cubic polynomial, that is the highest power is 3 here, and we are going to divide this cubic polynomial by this linear polynomial. Okay, we have seen how to divide a polynomial by the another polynomial. Okay, and some of you not understood, that is really it may be complicated. Okay, but it is very important concept. How can we divide this one polynomial by another polynomial? Because in 10th standard you are going to see this is one of the section of the chapter. Okay, let us see how to divide this polynomial by the another polynomial. Okay, so look at here. So this is dividend, that is a cubic polynomial. Now we are going to divide this by this divisor. Okay, so when we have to stop the procedure, it is very important. So after dividing each stage, you will get one remainder. Okay, and we have to check the degree of all the reminders in each stages and compare the degree of the remainder in each stage with this divisor. Okay, and if the degree of the remainder is less than the degree of the divisor, stop the procedure. Or the degree of the remainder is equal to the divisor or greater than the divisor, continue the procedure. Okay, continue the process, right? Now we are going to write the quotient here. Okay, here how can we write the first term of the quotient, right? So the procedure is, first we can divide this first term by the first term. Okay, so 2x cube divided by x. Okay, so x means x to the power 1. Next we have to first we have to cancel the variables powers. Okay, so here power 3 is there, here power 1 is there, right? So just um, divide the variable powers now. Okay, how can we divide? We have to subtract the powers. So here power 3, here power 1. If you subtract means the remaining power 2. Okay, now what about the remaining value here? 2x square. So that will be in our first term of the quotient, 2x square. Then after that, we are going to multiply this quotient with all the terms of the divisor. Okay, so when we multiply these two, what will happen? So 2 and x power 1 here and x power 2 here. So 2x cube will come. That means the first terms always the same. Okay, and then multiply this one with second term. So 2 twos are 4 and also positive symbol. Here also positive, here also positive. So positive symbol. Okay, so 2 twos are 4 and the variable is x square, right, as it is. Okay, right? Only two terms are there. Suppose three terms are there means you can multiply with that terms also and write it here also. Okay. And next we are going to change the sign of the down expression. Okay, not the upper expression, down expression. So here this is the positive, so we can change the sign as negative. And similarly here positive, we can change this as negative. Then the first term here 2x cube. Then after changing the sign, we have to consider that particular sign only. Okay. So here 2x cube, here minus 2x cube. So both are get cancel each other. So in each stages, we are cancelling the first term automatically like this. Okay. So now simplify this. Here minus 3 is there and here minus 4 after changing the sign. So how can we simplify this? Both are same sign, so we have to add. So minus 7. So here minus 7 and write the variable as it is. That is x square as it is without change anything. And down the other expressions as it is. That is plus 4x plus 5, right? So next we are check the, this is a reminder, check the degree of the remainder. So here x square x, so here power 2 is there, so the degree of the remainder is 2 and compare with the degree of the divisor here. So the degree of the divisor is 1, so this is more than this one, so we have to continue the procedure. Okay, next we are going to write the second term of the quotient. How can we write the second term of the quotient? So again the same process, we are going to divide the first term by the first term. Okay, this is the same procedure in each stages, right? So 7x square with minus and divided by here x, that is x to the power 1. Okay, so we have to reduce the powers of the variables. So here power 1, here power 2, so remaining power 1. We have to subtract the power. Okay, so minus 7x to the power 1. So right here minus 7x. Okay, x or x to the power 1. So next we are going to write, or we are going to multiply the new term with all the term of the divisors and write it here. Okay, so here minus, so minus 7x, so here x, when you multiply this 7x square, always first term will be equal, you can write as it is. Okay, and next we are going to multiply the second term with this one. Okay, so minus here plus, so minus, so 7 2s are 14 and the variable x is there, so x. Okay, so now we have to change the sign of the denominator, that is down expressions. So here minus is there, so plus, and here minus is there, again plus here. Okay, so here minus 7x square, here plus 7x square after changing the sign. So they are different sign with the same expression, so they get cancelled each other. In each stages, the first term will be cancelled definitely. For that purpose only, we are changing the sign of the down expressions. Okay, next simplify this. Here plus 4, here after changing plus 14. So plus 4 after changing the sign plus 14. So both are same sign. So when we add 18, so here 18 and write the variable x as it is. Okay, and then next down the next number here, that is plus 5. Okay, now this is the remainder in this stage, second stage. What is the degree of the remainder now? So power 1. What about the degree of the divisor here? Power 1. So compare the degrees, both are same. Therefore continue again. Okay, it is less than means you can stop it, right? So continue again. Next we are going to write the next term of the quotient. How can we write? Again, you can divide the first term by this first term. Okay, so 18 x to the power 1 divided by, here x is there. Okay, x to the power 1. So here also x, they get cancel each other. So remaining 18 only there. So write here 18. So plus 18. Okay. And then multiply this 18 with these two terms and write it here. So when we multiply, the same term will come in the first as, so 18 x to the power 1, and second term with the second term, so 18 2s are 36. So 36. Next, change the sign of the down expression. So here minus, and here also minus. So the first term will cancel each other. So here plus 5, here minus 36. So plus 5 and minus 36. Okay. So different sign. So subtracted. So here 36, here 5. So when we subtract this, so minus 31. Okay, so minus 31. Now check this is a reminder in this stage. Check the degree of the remainder. Here variable is nothing. Therefore, the degree of the remainder is 0. Okay, and what about the degree of the divisor here? 1. So, the degree of the remainder 0, and here degree of the divisor is 1. So, the degree of the remainder is less than the degree of the divisor. So, stop the procedure here. Okay, now this is your required quotient, that is, and this is your remainder. Okay, so 2x square minus 7x plus 18. So this is the quotient of the polynomial when we divide this one by this one, and this is your remainder. Okay, look at the next example. So the same thing here. Okay, so we are going to divide this one by this one. So this one also cubic polynomial here. So how can I write the first term of the quotient? Divide this one by this one. So 2x cube divided by 2x. So this 2 get cancelled, and if you cancel x means remainder 2 here. So x square will come here. So multiply this with 2 coefficients. Okay, that is 2 terms of the divisor. So 2x cube, the first term will come as it is, and the second term, so 3 into x square, 3x square. Okay, so now change the sign of the down expressions. So here minus and here minus. So this term will get cancel each other. So here plus 7, after changing this minus 3. So plus 7 minus 3. So when we simplify this, plus 4. So 4x square, and down other two expressions here, that is 2x plus 9. So look at the degree of the remainder. So power 2, and degree of the divisor 1. So continue the process. How can I write the next quotient, next term of the quotient? Divide this one by this one. So 4x square and divided by 2x. So here 1 2, here 2 2s are 4. And when we cancel the power 1, so 2x to the power 1. So here plus 2x to the power 1. So when we multiply this number and with these two numbers, the first term will be the same, that is 4x square, and second term plus 3 here 2. So 3 2s are 6x. Okay, now again change the sign. So here negative, here also negative. So they get cancelled each other. So here minus 2, and after changing the sign here also minus 6, plus 2, and after changing the sign minus 6. So when we that is simplify this, we get minus 4. So minus 4x plus 9. Okay, and then again, so here the degree of the remainder is 1, and the degree of the remainder is 1 here. Divisor is 1. So both are same. Therefore, continue the process again. Again, how can I write the third term here? So divide this first term by this first term. So minus 4x divided by 2x. So this x get cancelled here 1 time, here 2 times. So minus 2. So write minus 2 here. So when we write minus 2, the first term will be the same, that is minus 4x as it is, and multiply the second term alone. So 3 2s are 6, and minus is there, so minus 6. Okay, when we change the sign, so this will become plus, and this will become plus. Okay, so they get cancelled each other, and here plus 9 plus 6. So plus 9 and plus 6, when we add 15. So 15. Now look at the what is it? Degree of the remainder. So the degree of the remainder is 0 here, and here the degree of the divisor is 1. So this is less than this one. So stop the procedure, right? So this is your quotient, and this is the remainder. Okay. So let us continue the sums in the next video.